All right, I am going to be going over some problems from 6.5, equations containing radicals. So I'm going to start off with question 9 right here. So we have the square root of 3x plus 4 is equal to x. So because we have our variable inside of this radical, inside of this square root, we're going to need to get rid of that square root, get the variables out of there. And the way we do that is using exponents. So I am going to raise this side of my equation to the second power, and I'm going to raise this side of my equation to the second power to keep it, well, an equation, keep it equal. All right, so doing that, the square root and the second power cancel each other out. And x to the second power just becomes x squared. When you do this to solve an equation, you have to be careful. Anytime you raise both of sides of your equation to a second power, you introduce possible extraneous solutions. So solutions to this equation, but not to the original one. But you're not getting rid of any solutions. So whatever you get here is a possible solution to that original one. All right. So now we need to solve this. This is kind of a regular quadratic. Since my x squared term's on the right, I'm just going to go ahead and move everything over to the right. Okay, so doing that, I've moved over the 3x and the 4. And now I need to factor this. I need two numbers that multiply to -4 and add to -3. So that's going to be -4 and 1. So that tells me this factors as x minus 4 and x plus 1. And those two solutions, using my zero product property, I'm going to get x equals 4. That would make that 0. And x equals -1. That would make that 0. All right. I already have my suspicions about this as a possible solution. I expect this one might be extraneous because when I plug it in here, I'm getting -1. But when I take the square root of something, I don't usually get a negative. So anyway, let's go ahead and plug these two numbers in to check our work. So I'm first going to plug in 4. So 3 times 4 plus 4 is equal to x, which is 4. So I plugged it in for the two x's, and now I'm going to evaluate this. 3 times 4 is 12, plus 4 is 16. Yeah, this works out. The square root of 16 is 4, so this solution's good. All right, go ahead and do the next one. We have the square root of 3 times -1 plus 4 equals -1. Multiplying this, we get -3 plus 4, so the square root of 1 is equal to -1. All right, well, now technically the square root of 1 can be a negative value, but in general, when we evaluate things with square roots, we do not consider the negative root. So that's telling me that this is an extraneous solution. So the only solution to the original equation here is 4. All right, second problem I'm going to go over is number 7. I know I'm going a bit out of order, but this one was kind of different than the other one. Okay, so first thing to notice is we don't have a regular square root, we have a cube root, so I'm going to be cubing to get rid of that, raising to the third power. But before I can do that, I actually just want to get rid of everything else that's on the side of the radical. So I'm going to get rid of that by subtracting 7. I'm going to have the cube root of 4x equals -2. 4. And now, again, to get rid of any radicals, I raise them to the appropriate power. So to get rid of a cube root, I'm going to cube it. Keep moving on here. I got 4x equals -8, because -2 times -2 times -2 is going to be a negative. And then divide by 4, get x equals -2. All right, so now I'm going to go ahead and check this answer. So I'm going to plug this in. Cube root of 4 times negative 2 plus 7 equals 5. So this is the cube root of negative 8 plus 7 equals 5. The cube root of a negative number is always negative. And then the cube root of 8 is 2. So negative 2 plus 7 equals 5. Yeah, that checks out. This is a solution, and we're good to go. All right, and now for the last problem on this page that I'm going to go over, number 17. This one is pretty difficult, pretty time-consuming. A lot is going to happen here. So the first thing that you'll notice that's different than the others is I have 2 radicals. In this case, they're both on the same side, but really it just matters that there's 2 separate ones. I'm not going to be able to get rid of both of these radicals at the same time. So what I'm going to do is I'm going to isolate one of them. I'm going to get one of them all alone on its side. So what I'm going to do is I'm going to get this one all alone on the left side, which means I need to move this square root of a minus 4 over to the other side. I'm going to do that by adding it, since it was subtracted. So I'm going to do the square root of a minus 4. Okay. And I'll just rewrite this whole thing since it'll be a little neater. All right, now we're all set to get rid of the square root that's on the left side of the equation. And we get rid of square roots by squaring. So this side, easy. We just end up with 3a plus 5. Over here, however, a little bit more complicated. So I'm going to have to multiply this all out. So remember what we're doing is we are multiplying 2 plus the square root of a minus 4 times 2 plus the square root of a minus 4. Right? That's what that exponent's telling me to do, is multiply it by itself. So I need to do FOIL, or this sort of double distributive property, or a box, or whatever I want to do to multiply this out. Multiply 2 times that, and 2 times that. So that's going to be 4. 2 times 2 is 4. And then 2 times the square root of a minus 4. And then I need to do on this side, I need to multiply the square root of a minus 4 times 2, which is 2 square root of a minus 4. And then I need to multiply the square root of a minus 4 times the square root of a minus 4, which is just going to give me a minus 4. No square root anymore. Combining some like terms here, I have a plus 4 and a minus 4. Those can cancel out. I have 2 square root a minus 4 and 2 square root a minus 4. Those can go together to be 4 square root of a minus 4. And I still have this plus a. Right, I combined these and I have that, yeah. So just wanted to double check I had everything accounted for. There's a lot of little places you could just make a small mistake and it would be difficult. All right. I am now going to try to isolate this. I want to get this all by itself here because I'm going to have to square again to get rid of this square root. Subtracting a, subtracting a. Get 2a plus 5 equals 4 root a minus 4. Cool. We are getting closer and closer with each step. Now, I want to get rid of this last radical that I have. Square both sides. This side, I'm going to have to actually multiply out. That's going to be 2a plus 5 times itself. I'm going to take this a little faster. This is 4a squared plus 20a plus 25. Go ahead and multiply it out on your own if you're having trouble with that. Here, squaring this, 4 squared is going to be 16. And then squaring that, we're just going to end up with a minus 4. It just cancels out the radical. Go ahead and distribute that in. (16a minus 4 times 16 is going to be 64. We're getting closer and closer again with each step. Let's see, subtract 16a. This is a regular quadratic at this point. And then add 64. It's going to give us 0 on one side, which is what we were going for. That's going to be 89. 89, yeah. Whew. All right. Now, this whole process now has come down to this point here where I am solving a quadratic equation. Provided that this quadratic equation has some solutions, those will be potential solutions to our previous problem. This one is going to be quite difficult to factor by hand because we're dealing with 89. We're dealing with some pretty big numbers, and if I go to set up a diamond problem, yeah, I'm going to run into quite a lot of trouble. So what I'm actually going to do in this case, because the factoring seems like it's going to be difficult, is I'm going to go ahead and go straight for the quadratic formula. I have my suspicions that this might actually have no real solutions, but let's see what we end up with. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. Yeah, okay, just looking at that discriminant, the inside of the square root here, I'm going to end up with a negative value, which means that I will not have any real solutions to this quadratic, which means our previous problem obviously also doesn't have any real solutions. But I'll take this just the extra step just to show that. So 16 minus 4 times 89, it's going to be negative 1,408, which, yes, is what I was expecting. Yeah, negative in here. So this problem has no real solutions. And that's it. Unfortunately, a lot of work, like a whole paper full of work, and we ended up with no real solutions, but that's what happens sometimes.